Hey everyone, it's Justin again. Do you remember solving one-step equations in the previous unit? Well, in this lesson, those equal signs are going to be inequalities instead. And the great thing is that we solve these the same way, except there is one very important trick to know about that we'll go over in this video. First, let's go over solving one-step inequalities that involve addition and subtraction. This example says, to solve for x in the inequality, 4 is greater than or equal to x plus 6, and show the solutions on a number line. You may remember from the previous unit using these questions to guide your thought process, so I thought I'd show them to you one more time. If you find them helpful, you can continue to use them to guide you. So what do you think we should do to solve this inequality? Since 6 is being added to x, to cancel it, or undo it, I'm going to subtract 6. Let's give ourselves some space to do that here. When we subtract 6 from both sides, we have -2 on the left and just x on the right. Then we carry down that same inequality that we had in the original problem. Also, remember from the previous lesson, if you prefer to write your inequality with x on the left, then you can switch the place of the left and right side and flip the inequality symbol. Now, we haven't completely done what the question is asking, but we're close. The solution just needs to be represented on a number line. Think back to what you learned about this in the previous lesson. How would you show this expression on a number line? We need a closed circle at -2. Then, using either of these statements, which way does the arrow on the number line need to point? Both of these statements tell us that the rest of the solutions are all numbers smaller than -2, so the arrow must go to the left. Another way to make sure our arrow placement is correct is to substitute in a number that is in the direction we believe the arrow should be pointing, just to make sure that it creates a true statement. Like, for example, -5. The arrow is telling us that this should be a solution, so let's double check. Substituting -5 in for x gives us that 4 is greater than or equal to -1. Is that true? Yeah, it is. Now we can be extra sure that our number line representation is accurate. Now it's your turn to try a problem like this on your own. This says to solve for x in the inequality x minus 7.5 is greater than 13. And show the solutions in interval notation. Pause the video now and complete this one on your own. You should have added 7.5 to both sides of the inequality and gotten that x is greater than 20.5. Then, writing this in interval notation looks like this, with a parenthesis next to the 20.5 to show that it's not included in the solution, and all numbers greater than 20.5 represented by an infinity symbol and another parenthesis. Now, we've just worked on one-step inequalities containing addition and subtraction. But what about if there's multiplication and division? This is still approached the same way as in the previous unit when we focus on undoing the operation, but there is one important thing that didn't apply when we had equations. Let me show you using this problem. We need to solve for x in the inequality -6 times x is less than 27. To cancel or undo multiplication, we use division, so we have to divide both sides by -6. This gives us x on the left and -4.5 on the right. Now, here's the super important new concept I've been telling you I'd show you. We don't write the same inequality down whenever we multiply or divide by a negative number. When multiplying or dividing by a negative number in an inequality, we have to flip the inequality. This only applies when multiplying or dividing by a negative number, not a positive number. So, since we divided by a negative number in this problem, what symbol should we put here? Yep, we originally had a less than symbol, so we'll change it to a greater than symbol. You're probably wondering why we need to flip the inequality whenever we're multiplying or dividing by a negative number. Well, think about it like this. If you had a true statement, like 2 is greater than 1, and you multiplied both sides by -1, it would then become the statement -2 is greater than -1. Is this statement true? It's not. But if we flip the inequality sign, then it's true. There's more information about this in your PDF to explore when you finish this video. But for now, the fact is that this rule only applies when multiplying or dividing by a negative number, not a positive number. That's what you need to make sure you remember. Anyways, our original problem didn't specify a way to show the solution, so an inequality will work just fine here. All right, now it's your turn. Pause the video and solve this problem on your own. Remember how a negative sign isn't grammatically correct to write in the denominator, but it wouldn't technically be wrong? Well, that's super helpful here because we can move the negative down to the 10. Then it's easier to see that x is being divided by -10. So how do we undo this division? Yep, we have to multiply by -10 on both sides of the inequality. And what does that give us? We have 40 on the left and x on the right. And the inequality now has to change from greater than or equal to less than or equal to. Now, can you explain why our inequality changed? Was it because we had a negative here in front of the 4? Or because of the negative in front of the 10? Yes, it was because of the negative in front of the 10. We had to flip the inequality sign because we multiplied both sides by this negative number. Be sure to pay close attention to this on your practice game. If you see a problem like this that has a negative in it, don't just assume you'll flip the inequality. In this case, you'd only be multiplying by +10, and that does not require an inequality flip. All right, back to the original problem. Did I answer the question that was originally asked? Oh, no, I didn't. We need this answer on a number line. I guess I'll flip this all around so it's easier to read. This says x is greater than or equal to 40. Okay. So closed circle at 40. And x can be greater than this, so my arrow goes to the right. This is it. We got it. Now you can solve one-step inequalities. Remember to flip the inequality sign whenever you are multiplying or dividing by a negative number. And don't forget about those important skills from the previous lesson of being able to show the solution set in different ways. You'll be continuing to use those skills in this lesson's practice game, which you'll be working on next, but also in many other places in the future. Good luck, and I'll see you next time!